Okay, so welcome to this lesson. We are looking at the introduction to matrices. Okay, and as you can see on your screen, I've outlined the objectives of this lesson. Okay, so we shall look at the definition of what this matrix is. Okay, we shall also look at the order. Some people or some literature say the size of the matrix. We shall look at what a square matrix is. Okay, and then for the sake of your revision, we shall look at the addition and the subtraction of matrices and even some multiplication there. Okay, and then from there we'll look at some important uh, properties of what these matrices. Okay, so we begin with the definition there. Okay, so we are seeing the question there: define a matrix. Okay, so a matrix is simply a matrix is simply a rectangular it's simply a rectangular array of numbers. So this is the definition of what a matrix is. Okay, so a rectangular array of numbers. Okay, so meaning it can be represented in this form. Okay, so you have your first row there, maybe A B C D, A B C, and then you have D E F G H, maybe I. Okay, so this here is in the form of a rectangle. Okay, and then it has this array of what numbers that have been represented by these letters. So this here is simply the definition of what a matrix is. Okay, and then these numbers here inside this matrix, okay, these numbers inside these matrices or this matrix here are called entries of the matrix. Okay, are called entries of the matrix. Okay, so that's the definition there of a matrix. Okay, and then we can move to talk about the order of the matrix. Okay, so what is the order of the matrix? How is it defined? Okay, some people say the size of a matrix. Okay, so the size, or we can say the order of this matrix, is described in terms of the number of rows and columns. Okay, number of rows and columns. Okay, so we describe the order and the size by this number of rows and what columns. Okay, so for example, if I have this matrix here, okay, let me say 2 1 3 maybe 4 7 9, we have a 10 there, 0 4. Okay, so let's say this is my matrix A. Okay, this is my matrix A. So we can describe the order of the size of this matrix by counting the number of rows, okay, and then multiplying them by the number of what columns. Okay, so we must know that this number of rows here, okay, rows go in this direction like that, they are horizontal. Okay, and then the columns go vertically like that and go into the bottom like that. Okay, so whatever you see that is vertically, okay, it's called a column, and then whatever you see that is horizontally there, it's called a what, a row. So in this case we are just going to count the number of rows and then we multiply by the number of what columns. So we are going to say the size indicated by n of this matrix here is just how many rows do we have. Okay, we have this row, 2, and then 3. Okay, so we are going to say the number of rows are just 3. Okay, and then how many columns do we have? We have 1, we have 2, and then we have what, 3. So it means the order here of this matrix, or the size, will just be a 3 by 3 what matrix. So that's what we use to describe the size of a matrix. Okay, we use the number of rows and columns. So for example, if I add another matrix here, okay, let's say this matrix had A and B and then C and D. Okay, so if we count the number of rows here, we see that the number of rows there are just going to be 2 multiplied by the number of columns are also 2. So it means the order of this matrix here is just a what? A 2 by 2 matrix. Okay, right. And then when we are looking at the order of these matrices, we have some special matrices that you should be aware of. Okay, so I'll mention those two special matrices that you should be aware of. So the first matrix that you should be aware of is what we call as a column matrix. Okay, so what is this column matrix there? So a column matrix is a matrix, okay, with only one column. Okay, column matrix, it means only one column in that matrix. Okay, so you can have any number of rows, but as long as the column is just one, then we call that as a column matrix. So for example, we can represent it in this form. We can say A, B, and then C. Okay, so we can see that if we describe the size of the order, or the order of this matrix, it will be 3 by 1. Okay, so the number of columns there are just 1. So this here is a column matrix. Okay, and then another one is what we call as a row matrix. Okay, a row matrix. Okay, here I should have written a column. I should have written matrix there. Why did I write column? Okay, so that's a column matrix there. And then we also have a row matrix. Okay, so we use the same concept to define what a row matrix. It's just a matrix, okay, that has the one row. So you can have A, B, and what? C. Okay, so you don't put commas there. Why am I putting commas? So we have A, B, okay, and C. So this one here will be described as a row matrix. Why? Because I have one row, so its size will just be 1 by what? 3 matrix. So the number of rows, we only have 1. So we call that as a what? A row matrix. Okay. And then from there we talk about some other matrix that is special in terms of the order. Okay, so this matrix is what we call as the square matrix. Okay, so if I have a matrix A, okay, I have a matrix A, for example, if I have matrix A, and then this matrix A, okay, has n rows, and it also has n columns. Okay, so meaning the number of rows and the number of columns are equal. Okay, so if the number of rows and the number of columns are equal, then we describe that matrix as a square matrix. Okay, we describe it as a square matrix, and then the order or the size, we can just say the size will just be n. Okay, will just be n, or you can say n by n. It will still mean the what? The same. So a square matrix is basically a matrix that has the same number of rows and what? Columns. So for example, I can write matrix A to be, okay, I write 2, 3, 4, 5. Okay, so we see that in this matrix we have 2 rows, and then we also have what? 2 columns, like that. So the order of this matrix will just be a 2 by 2. Okay, so order will just be what? 2, or you can say 2 by 2. Okay, so this is a column matrix here because we have the same number of rows and columns. Okay, so other square matrix will just need to have the same number of rows and columns. It can be 3 by 3, it can be 4 by 4. Okay, it can even be 5 by 5. Okay, as long as the rows and the columns are equal, then we call that matrix as a square what? Matrix. Okay, so when you talk about the square matrix, okay, it means we have special entries in the what? In the diagonal. So I hope you remember what the diagonal is, okay, from your first year or your secondary school. Okay, so if I have this matrix here, let me just use a 2 by 2. So if I have A, B, and then C and D, okay, we said this diagonal here, okay, this diagonal here, that goes like that. We said that was our what? Our major diagonal. Okay, and then this diagonal that goes like that, we said that was the what? The minor diagonal. So it's very important to know this in case you are given to find the determinant of a 2 by 2. So how were we finding the determinant of a 2 by 2 back there? We used to say you multiply what is in the main diagonal, which is just AD, and then minus, you multiply what is in the minor diagonal, which is what? AC. So this is how we used to find the determinant, right? So it's very important to know that these entries here, okay, in any square matrix, as long as it's a square matrix, there will be diagonal what? Entries. They will be referred to as diagonal entries. So let's say I have this matrix here. Okay, let me draw up a bigger matrix, like maybe a 3 by 3, or let me just make it arbitrary. Okay, so let's say I have this matrix here. So I have matrix where I have the first entry on row 1, column 1. Okay, so this here means first row, first column. Okay, and then I have another one, first row, second column. Okay, another one, first row, third column, and then we continue just like that until we reach the first row and then the nth column. Okay, so this is my matrix, and then when we are going down now, it will be this here is the second row, so I'll write A2, meaning in the second row, right? And then first column, this will be the second row, second column. Okay, this one here to be the second row, third column, and then we can continue going like that until we reach the value second row and then nth column. Okay, so remember here I'm writing up a square matrix. Okay, so meaning let's write 2 more there, and then here to be 3 3 2. Okay, then there to be what? 3 3, and then dash dash dash, we are in the third row and then nth column. Okay, and then here I can go dot 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 until I reach the what? The nth row and then first column. Okay, even here I will go to the nth, I'm still in the nth row, second column, nth row, third column, and then I go dash dash dash. This will be the nth row and then the what? The nth column, like that. So these entries here, okay, so these entries here that are in the main diagonal here, these ones that I'm circling in red, okay, they will be called diagonal what? Entries. And you can see they have something common about them. If we have an entry there, it will just be 1 1 2 2 3 3 4 4 5 5, just like that, as long as a square matrix. Okay, all those entries that we have the form where the numbers are repeating, they will be in the what? The main diagonal, like that. Okay, so that's it about what a square matrix is. And then let's look at the addition and subtraction of what? Matrices. Okay, so I know you guys know this. So the subtraction and addition is not hard, so you just add term by term or entry by entry. Okay, but the governing principle when you're doing addition and subtraction of matrices, okay, is that those two matrices should have the same what? Order or size. Okay, so those two matrices should have the same order. Okay, the same order or size. Okay, that's the only way you can add two matrices. Okay, so let's give an example here. if I have A is equals to, okay, and then I have 2 1 0 4 as my first matrix, okay, and then I'm adding this matrix to matrix B, which is given by, let's say, 0 4 and then 3 9 there. Okay, so when we're adding these two matrices here, we add them entry by entries, meaning the first entry here should be added to the first entry there, the second one should be added to that one, just like that. Okay, so we add entry by entry. Okay, so it means our matrix A plus B will just be equals to, okay, the first entry is 2 in here, so we are going to say 2 plus 0, and then 1 plus 4, that there it will be 0 plus 3, and then here it will be 4 plus 9. Okay, and then you can find the final values here, so it means your matrix A plus B will just be 2 5 3, and then you have a what, a 13 there. Okay, so you can see that we are adding entry by entry. Okay, so that's the important property that you should know when it comes to addition and subtraction. The two matrices that you are either subtracting or you are adding, they should have the same size, okay, or the same what, order. Okay, so for subtraction you also what, do the same thing. Okay, so this is for your revision sake, okay, but in this course you will never find such a question where you are adding two matrices. No, okay, it will always come with something that is conceptual. Okay, you have to apply a concept that you learned somewhere. Okay, so it won't come as a direct question. So maybe I should show you. So for example, this question here, okay, so this question here, can you see this question here? Okay, that can be a question that can come close to what addition is in matrices. Okay, they won't give you a direct at add this, no. So you can see here we are using to the concept of addition of matrices to find the value of x, y, z, and t. Okay, so we have this question here. Okay, so we'll solve this question at the end, and then let us continue here. Okay, so that's it about the addition and the subtraction, and then we can talk about the multiplication. Okay, so the multiplication, okay, let's say I have matrix A, okay, that has order. Okay, let's say I have matrix A that has order m by n, okay, m by n, and then I have another matrix B, okay, that has order maybe P multiplied by what, Q. Okay, so these two matrices here, you can only multiply them, okay, you can only multiply them if n is equals to P. Okay, so if this number here is equals to P there, then you can what, multiply your matrices. Okay, so if you have two matrices where this n is not equal to this P, then you can't multiply those two matrices. Okay, multiplication won't work on those two matrices. So you have to make sure that the number of columns in the first row is the same as the number of rows in the what, second matrix there. Okay, so why is it that? Oh, why is it like that? Okay, so if I have matrix A and B, okay, and then I want to find their product, okay, so each entry in the matrix A and B, okay, will be of the size m multiplied by Q, and will only be valid if n is equals to what, to P. Okay, so when you multiply these two matrices, the order of that matrices that you get after you multiply A multiplied by B will be a product of M multiplied by Q, and then this product here can only exist if and only let me not say that let me not that use if and only if. Okay, it can only work if the n is equals to the p. So let's give an example there. Okay, let's give an example. So let me draw up two matrices there. Okay, let me draw up two matrices there. So I'll just use arbitrary matrices. So let's say A is equals to the matrix A, B, C, D, and then the matrix B is equals to, let me say, E, F, and then I have G, H here. Okay, so the matrix A multiplied by B will just be, okay, we'll be multiplying rows by columns. Okay, so you get the rows there and then you multiply it by a column. So I'm going to get the first row here and then I'm going to multiply it by the first column here. Okay, so what does that mean? You get the first entry in this row, you multiply it with the first entry in this column. So it will be A multiplied by E. Okay, so A multiplied by E, and then you say plus B multiplied by G. Okay, so it will be B, G there. Okay, so we've multiplied this first row with the first column. Okay, and then now we multiply that first row, this same first row here, we multiply it with the what? The second column. So it will be AF plus BH. Okay, so we are done with the what? The first row. And then you go to the second row here, which is CD here. Again, you also multiply it by the first column and then the second column. So it will be C multiplied by E. You are going to have CE, and then D multiplied by G. You are going to have DG. Okay, and then this C and D, you multiply it with the H, F and H here. So it will be CF plus DH. Okay, so this one here will be the product of the two matrices. Okay, so you can see that this product is only possible because the order of A is 2 by 2, and then the order of B is also 2 by 2. So the number of columns in the first matrix is equal to the number of rows in the second matrix. No wonder this multiplication is possible. Okay, and then the new matrix that you are going to get will be of the order 2 multiplied by 2, and we see that it's still a 2 by 2 here, right? Okay, so let's maybe give a specific example there. Okay, let me give a specific example there with different rows and number of columns. Okay, so multiplication of matrices. Let's say we have A is equals to 2, 4, and then 0, 1. Okay, and then B. Okay, let's say we have what matrix? Okay, so let's say we have 1 and 2 there. Okay, so before we multiply these two matrices, you check the order. So the order of this one is a 2 by 2. Then the order of this one is what? 2 by 1. Okay, so as long as these two numbers there, they are equal, then we can multiply. Okay, so B multiplied by A multiplied by B will just be equals to 2 multiplied by 1, we are going to get 2, then plus 2 multiplied by 2, we are going to get 8. This, I mean 4 multiplied by 2 here, we're going to get 8. And then 0 multiplied by what? 1, we are going to get 0, plus 1 multiplied by 2, we are going to get 2. Okay, so our matrix AB will just be 10 and then 2. So we see that the order of this product here, okay, is just a 2 by 1. Okay, so the middle two numbers here give you will enlighten you if these two numbers these two matrices are multiplicable. Okay, and then these others will give you the order. Okay, so that's the multiplication of matrices. Okay, later on we'll talk about the properties of this multiplication, addition, we'll see. Okay, so any questions there, guys, on so far what I've talked about? Any question? Okay, no question. It means there are no questions. Okay, and then now we can talk about the very properties of matrices. Okay, so these properties here, guys, are very, very important, because without them, trust me, you will not solve any question. Okay, if you don't understand the properties, you will not solve any question. You have to understand the properties. Okay, because the questions will be based on the application of what these properties. So very important. Okay, so some of the properties of these matrices. Okay, some of the properties of these matrices. Okay, are, okay, so I'll say um okay, I'll say let A, B, and C, okay, be of appropriate orders, be of appropriate orders, okay. Then the following properties hold, okay. Then the following hold. Okay, so the first property is on commutativity. Okay, so you remember your binary operations from first year. Okay, so the first property there will be on what? Commutativity. So the addition of two matrices is commutative. Okay, so A plus B is actually the same as B plus A. Okay, so it doesn't matter the order in which you add your two matrices, they will always give you the what? The same answer. Okay, and then two, we can talk about associativity. Okay, so associativity, remember we are associating three, back in first year we are associating three sets, right? Okay, or three items. So here we are associating three matrices. So addition of matrices is also what? Associative. So meaning that A plus, and then in the brackets if I have B plus C, this here is the same as A plus B, okay, and then plus C. So addition of matrices is associative. Okay, is associative. And then three, we can look at scalar multiplication. Okay, so scalar multiplication simply means we are multiplying a matrix by a number. Okay, we are multiplying a matrix by a number. So let's say I have two scalars here, maybe D and K. Okay, so I have two scalars. These scalars are just numbers. So from your physics in first year, scalars are just numbers, right? So if I multiply D multiplied by K, and then I come and multiply with a matrix, this here is the same as multiplying the matrix first with the K, okay, and then multiplying by the D there. So it will give you the same answer. Okay, if you multiply first of all D multiplied by K and then you multiply by the matrix, it will be the same as you first multiply K with your matrix and then you multiply by D. It will be the same. Okay, so that's the third property that you should take note of. Okay, and then maybe we can do a question on this. So let's say let D be half, and then K be 3. Okay, and then let's have a matrix A here, maybe 2, 5, 7, 8. Okay, so this is the matrix that we have. So let's first of all start with multiplying the two scalars there. So if we multiply this D and K, we are going to get 3 over 2, and then this 3 over 2 we multiply by the matrix that we have there. Okay, multiply by the matrix that we have. So what are we going to have? We are going to have, okay, we are going to have this 3 over 2 multiplying by whatever we have there. Okay, by multiplying whatever we have there. So 3 over 2 multiplied by this, you are going to get 3 over 2 multiplied by this. The 2 and the 2 cancel, so we're going to get 3. 3 over 2 multiplied by 5, we're going to get 15 over 2. 3 over 2 multiplied by 7, we are going to get 21 over 2. 3 over 2 multiplied by 8, we are going to get 24 over 2. Okay, so you can see that we got 3, 15, whatever this matrix is. So in a case where you first start by multiplying this 3 with this matrix, okay, and then you multiply by half, you will still get the same answer here. Okay, you still get the same answer. So you should try out and confirm this property here at your own time. Okay, otherwise I'll continue to the other properties. So the fourth one, we can talk about distributive law. Okay, so distributive over a scalar. Okay, so let's say for example I have k. So this is number 4, right? So I have k and then I have a plus b as my matrices there. So this here is the same as ka plus kb. Okay, so this is the fourth property. And then the fifth one, we can talk about the associativity, okay, of multiplication. So multiplication is also associative, so you can say a multiplied by bc is the same as ab multiplied by c, okay, when you're multiplying these 3 matrices. Okay, and then you can also have the distributive law of a matrix over the sum of a matrix. So let's say I have a and then here I have a plus b as my matrices. Okay, this here is the same as a multiplied by b and then plus a multiplied by c. So remember, this a and b and c, guys, are matrices. Okay, these are matrices, they are not scalars. Okay, so these properties here hold, okay, as long as your a and b and c have what? Appropriate orders. Okay, and then now you notice that I didn't say anything about the commutative of multiplication. Okay, simply meaning that multiplication is not commutative. Okay, so multiplication of matrices is not commutative. Okay, so I'll say multiplication here of matrices is not commutative. So this here is where some of your exam question, tutorial sheet question, test question, quizzes are going to come from. Okay, so those special properties, you should be making sure that you understand them. Okay, because that's where you are, that's what they examine. Okay, that's what they examine you on. So multiplication of matrix, we are saying not commutative. Okay, not commutative. So what does this mean? It simply means that, okay, it simply means that a multiplied by b is not equal to b multiplied by a. Okay, a multiplied by b is not equal to b multiplied by a when you're multiplying 2 matrices. Okay, so make sure that you understand this definition. So multiplication of 2 matrices is what? Not commutative. Okay, so maybe we can do an example there. Okay, so a b is not equal to b a. Okay, all right, so let me say I have the matrix A, now 1, let's say 0, 3, 4, okay, as my first matrix, and then b, I have this matrix here, maybe let's say 2, 1, 7, 1. Okay, so if I find my AB here, AB will be equals to 1 multiplied by 2, that will be 2, 0 multiplied by 7 to be plus 0, 1 multiplied by 1 to be 1, 0 multiplied by 1 to be plus 0, 3 multiplied by 2, it will be 6, 4 multiplied by 7, it will be what? 20, is it 28? Yeah, so 28. And then 3 multiplied by 1, 3, 4 multiplied by 1, 4. So this here is our matrix A multiplied by what? By B. So we're going to get 2, 1, and then there to be 34, and then there to be 7. So now let's try to find the matrix BA. Okay, so the matrix BA, we are now multiplying this with the A. So let me write the A in front here so that I do the multiplication correctly. Okay, so we are saying now 2 multiplied by 1, that would be 2, plus 1 multiplied by 3 to be 3. Okay, 2 multiplied by 0, it will be 0, plus 1 multiplied by 4, it will be 4. And then 7 multiplied by 1 to be 7. 1 multiplied by 3, it will be plus 3. 7 multiplied by 0, it will be 0. 1 multiplied by 4, it will be 4. So you see that the BA here will be what? Will be 5, 10, 4, 4. So we see that this BA here is not equals to what? To AB. So communication man. So commutativity of these matrices, okay, is never what? True. Okay, so A, B will never be equals to BA as long as these are matrices. Okay. All right. Maybe it can work when you're using the identity matrix, because the identity matrix, when we come to linear algebra, is the same as 1. Okay, so when you multiply any matrix by the identity, it's the same as the identity multiplied by matrix. So this is the only exception, but the rest, as long as you have two distinct matrices and then you multiply them, they will never be what? Commutative. Okay, and then from there, guys, we can talk about the transpose. Okay, we can talk about the transpose of a matrix. Okay, so a transpose of a matrix of order n by m. Okay, so let's say I have matrix A here, and this matrix here has order, okay, it has order maybe m multiplied by n. Okay, this is the order of this matrix. So the transpose of this matrix A will be denoted by A with a T on top there as a superscript, okay, or a power. Okay, so this here would denote the transpose of this matrix A. So this transpose will have the order n multiplied by what? M. So what is really a transpose of a matrix? It's just simply interchanging the rows with the what? The columns. Okay, so let's say I have A here. So AB, and then C, and then D. Okay, and then I want to find the transpose of A. So transpose of A will just be what? So the row will become a column. So it will be AC. Okay, it was a row here that has become a column. And then this BD here, this should be D. This BD here, it was a row, it will become a column like that. Okay, so you can see that we've just interchanged the what? The rows and the columns. So that's what a transpose is. Okay, that's what a transpose what is. Okay, so let's look at another example here that contains numbers. Okay, so let's say my transpose, my matrix A is given by let's say 407 and then 1 minus 82. This is my matrix A. Then my A transpose will just be equals to what? Okay, my A transpose will just be equals to 407 and then 1 minus 8, 2. Okay, so this here will be my what? My transpose. Alright, so any questions, guys? Any questions? Any questions? Okay, no questions. Alright, so let's solve a practice question here using the addition. Okay, using the addition. So we have that okay, so we have that. Okay, so we have this question here. So we are using the properties of addition to answer this question. Okay, okay, so we have that find x, y, Z and T, where we've been given that 3 multiplied by this matrix is equals to x6 minus 1, 2t plus 4. We have 2 plus t there, x plus y, and then we have 3 there. Okay, so how can we find the value of this x, y, z, and t? Okay, so we are going to write whatever we have on the left, which is this t. Okay, and then on the right hand side we are going to add. Okay, so remember, when adding, make sure that the matrix or the two matrices are of the same order, and then we add entry by entry. So we are going to add this x to the 4, so it will be x plus 4. Okay, and then the other one to be 6 plus x plus y, the other one to be minus 1 plus 2 plus t. Okay, then the other one to be 2t 2t plus 3. So this here is what we have, and then on the left hand side here we see that we can multiply these 3 with the matrix there. So this is a scalar here, we can multiply this matrix with that scalar. So what are we going to get? We are going to get 3x 3y 3z. Okay, so we're going to get 3x 3y 3z and then 3t. So this is what we're going to get, and then from here now we can equate. Okay, so whatever is here, it means it's equated to that, because these two matrices are equal. Okay, so the first one to be 3x is equals to x plus 4. So it will be 3x minus 2 is equals to 4. So this here, I mean minus x here. So this will be 2x is equals to what? 4. So it means my x is what, guys? Is 2. So find the value of x there, and then let's try to find the value of another number. So we are going to say 3y is equals to 6 plus x plus y, but now we know the value of this x is just what? 2. So this will be 3y minus y is equals to 6 plus 2. Alright, so this will be 2y is equals to 8. Okay, 2y is equals to 8, and then this will give us what? Give us y is equals to 4. We divide both sides by 2. Okay, and then let's find the value of z. Okay, so we start with the t there, so we're saying 3t, this guy here is equals to this, so is equals to 2t plus 3. Like terms together, it will be 3t minus 2t is equals to 3. So this here will be t is equals to what? 3. Okay, and then now we can find the one for z. So the one for z, let's find it a bit on top here. So the one for z, we are having 3z. Okay, we're having 3z is equals to, then we have minus 1 plus 2 and then plus t. So that one is going to be equals to minus 1 plus 2 and then what? Plus 3. So this 2 plus 3 is 5 minus 1, is it 4? Okay, so we have 3z there, and then this 3z is equals to, okay, so 5 minus 1, we are going to get 4. So it means our z there will just be equals to 4 over 3, like that. Okay, so any questions there, guys? Okay, any questions? Is it clear? Alright, so thank you so much. So this was the lesson for today. Okay, so next time we have linear algebra, we are going to look at the properties of the transpose of a matrix, and then we are going to talk about special matrices like the zero matrix, the equal matrices, something like that. Okay, so these lessons will continue, but this one ends here.